We've now grasped a clear idea of what generative AI is, what it can do today, and how it differs from the traditional AI we've used in the past. But now let's go a layer deeper. You might be using ChatGPT daily, but is GPT the same thing as ChatGPT? You may have heard terms like transformers or diffusion models, but what do they actually mean? And do you really need to understand these technical details if your company wants to adopt generative AI? You might also be wondering, if we have a lot of data, where do we upload it? And is training a model even the right place to start? Let's break it down. To understand how generative AI works, let's break it down into three foundational layers. Layer 1 is what we've already seen, the GenAI products. These are the tools we interact with, like ChatGPT, Copilot, Midjourney, and others. They're designed to be user-friendly, safe, and business-ready. Layer 2 is the foundation models. These are the powerful engines behind the products, like GPT, Claude, DALL-E, or Music LM. They're trained on massive datasets to perform a wide range of tasks. And Layer 3 is the deep learning neural networks, the technical backbone that powers everything. These are the architectures that define how the models learn and generate content. Now, if we zoom out and look at the full stack, each layer builds on the one below it. GenAI products are powered by foundation models, and foundation models are built using neural networks. In the next slides, we'll explore how foundation models are developed and then take a closer look at the neural networks that make it all possible. Let's take a closer look at how foundation models are created. The process that transforms raw data into the powerful generative AI systems we use today. IBM breaks this down into three key steps. Step 1. Training. This is the foundation building phase. The model is trained on vast amounts of unstructured data, including text, images, code, and more, using self-supervised learning. It learns to recognize patterns, relationships, and structures in the data. This is what gives the model its broad, general-purpose capabilities. Step 2. Tuning. Once the base model is trained, it's tuned for specific use cases. This can involve fine-tuning with domain-specific data or applying techniques like reinforcement learning with human feedback. Tuning helps align the model with business goals, safety requirements, and user expectation. Step 3. Generation and evaluation. Finally, the model is deployed to generate outputs. Whether it's answering questions, writing code, or creating images. These outputs are continuously evaluated for quality, relevance, and safety. Feedback from users and evaluators can be used to further refine the model. Together, these three steps form the core workflow behind every foundation model powering generative AI today. Now, if you're wondering how these three steps actually connect to the AI products you use every day, like ChatGPT, you're asking the right question. Most people think they know the answer, but the real explanation usually surprises them. We unpack that full story inside the complete Udemy course. You'll find the link in the description below. Now that we've seen how foundation models are created, let's ask a deeper question. Why do we have different foundation models? What makes them different? The answer lies in the type of data they're designed to work with. Different modalities, like text, images, audio, and video, require different deep learning architectures and training algorithms to perform at their best. For example, language models like GPT use transformers, which are great at understanding sequences and context. Image models like DALL-E or Stable Diffusion use diffusion models, which are better at generating high-quality visuals. Audio and video models often rely on convolutional networks, recurrent layers, or hybrids. And the future is moving toward unified, multimodal models capable of understanding and generating across text, images, audio, and video. These models are not just more versatile, they're paving the way for more natural, human-like interactions with AI.